Brilliant. So, welcome everyone. Thanks a lot for taking the time, obviously, to dial in today. Fortunate enough to have Marcia with us from Amazon Web Services to give us a great chat, which I'll let her introduce. In essence, to intro myself and Oliver Bernard, we're a recruitment company by nature, but obviously in these strange times we're living in, as many companies do these days, looking at bringing the community together, trying to provide a platform for people to share their knowledge, have people speak on perhaps topics they're experts on, and share that information with others, and hopefully obviously at the end we'll have some exciting questions as well, and you'll be able to pick Marcia's brain as such. So will be recorded, so everyone feel free to watch it back. The content will be there for you to rewatch and cover again if you like. So updates will go through the group as usual. So yeah, Marcia, I'll hand over to you, let you take the reins, and yeah, look forward to it.
Cool. I think you need to enable that I can share my screen.
Yeah.
Yes, I cannot. So hey, hello everybody. I'm Marcia Villalba, and I'm a developer advocate for AWS. And I hope my cat doesn't jump on top of the camera because she's very needy. So today we are going to talk a little bit about my story and other stories as well on how to migrate an existing application to serverless. But if you have any questions, you ask them in the chat. They can be about this talk or about serverless in general. I'm always very happy to answer all kind of questions, and we can have a discussion at the end. That's my favorite part always. Let's see if my screen now allows me.
Should be able to now.
I can share my screen. Good. Let's see if I can put Zoom here. Good. Can you see my screen? Can you see my face? Awesome. So let's get started. So a little bit about me. I've been a developer advocate for around 9 months. Sometimes it feels like a day, sometimes it feels like forever. I think everybody says that's about working at AWS. It's always day one and it's always changing, so you never know anything. I've been doing serverless since quite early on in production. Serverless, what we call Lambda, that is the origin of the serverless word, was launched in November 2014. In July 2015, API gateway integration with Lambda was done, and around May 2016, I started my first production project with serverless. So I've been doing it for quite early on, and I've been doing it since I moved to serverless. I never turned back to do traditional development. I'm the host of a YouTube channel called Fubar, where I've been posting. Basically, I started my serverless journey in May, and I started posting YouTube videos in August, September of 2016. So there is around 250 videos of serverless, hands-on tutorials, how to do things. Basically, most of my learning process is recorded in that YouTube channel. So don't go to the first videos, please. Those are horrible. But the last 100 videos are quite decent, and I do all kind of explorations on really hands-on technical. We have the good GitHub repo. We go through everything in quite detail. So if you want to learn, I recommend to check that out. Also, my Twitter is open, so you can always reach me for questions, and that QR code takes you to my YouTube channel. So that's all about me. We can start now with the presentation. So I said I will talk about migrating to serverless, and I want to start the presentation by telling two stories. First one, a not that successful story when migrating to serverless, and then a more successful story. The first story is my personal story, my first serverless experience, because as most of us, we don't have a green field to play with. We need to always start with something that has been there, and we might need to migrate it. So that was our case. And the second case is the case of a customer with a really good kind of experience with serverless. They did the things right, and from there then we will move to some steps to summarize what a good migration can be. So The first thing I want to do is to give a little definition on what is serverless, because this is something that as it's a new concept, everybody has a different definition. So I think the most important concept for you to keep in mind is that serverless is a methodology, is a mindset. It's a mindset of maximizing the value that we bring to our users by minimizing the undifferentiated heavy lifting, meaning we don't reinvent the wheel. So serverless people might not use all the time serverless components because you can't for many reasons, but they have the mentality of trying to write the least amount of code and own the least amount of components. So this definition is given by Jeremy Daly. He's one of the AWS heroes for serverless. He's one of big influencer. He has a great newsletter and a podcast on serverless. So you can definitely look for him on Twitter and you will find all his amazing content. And then in the other side, we have Jared Short, that is another serverless influencer. And he summarized the methodology, the thinking behind serverless very well with this tweet, that if the platform has it, use it. So don't reinvent the wheel. Don't manage your own things just for the sake of having control. No, trust the platform and try to not reinvent the wheel if possible. And sometimes the platform doesn't have it or doesn't have exactly what you need, but maybe the market does, so buy it from there. And then if you can, sometimes the market doesn't have exactly what you need or the platform, sometimes even thinking about the requirements that you have is a good step, because most of the platforms might cover 80% of your requirements, and that 20% left might be not that critical or might not bring that much return on investment to spend so much time, money, and resources into build something yourself. And then if for any reason you cannot use someone else's piece of code or service or whatever, build it. But when you build it, you own it. So that's kind of a really good summary of what serverless is. Then when we have serverless components need to adhere to these 4 tenets. The first tenet, that it scales automatically, meaning that in an ideal world, you can leave your application, it can go viral in the other side of the world. At 3 in the morning, you're sleeping and your application can handle amazingly. And the other way around, it will shrink until 0 and you will not pay if you don't have traffic. This, what I say, is in a magical world, because in general, most of cloud providers have safety mechanisms in place. So you don't want your application to grow infinitely, because if somebody hacks you or you have some security issues or you do something wrong, then your bill will grow indefinitely and you don't want that. So there is always security mechanisms in place to give you some certainty that things will stay in some size that you can grow, but it's basically just sending a ticket and asking those limits to be raised. So it's just there for protection and nothing else. So nothing is forbidding you to scale as much as you need. Then the other tenet is for pay for what you use. That's basically was born with the cloud. The idea that you are not buying infrastructure beforehand or making an investment. You basically use the infrastructure. At the end of the month, you pay for it. It's like electricity or water or internet, all these utilities we have at home. Cloud usage is one of that. The other tenet is not managing infrastructure. And I'm not meaning not managing hardware, because with the cloud, we already remove the hardware layer. But even in the cloud, we need to install operating systems. We need to patch them. We need to think about firewalls. We need to do a lot of work that really doesn't provide any value to our customers. Our customers don't care if our application is in a Linux or in a Mac most of the times, or in a Windows, or they don't care. They want their applications to produce results and they want their data to be secure. But how you do it is your problem. So that's the idea of serverless. If it doesn't bring value, outsource it to someone else, and managing infrastructure, in most of the cases, is not producing real value to the end customer. And the last one is the high availability built-in. And this is something that, for example, if you're using AWS, when you're using virtualization, you need to decide in which availability zone you're going to deploy your virtual machine. So you're going to say, well, I'm going to try the London region, and there you need to pick the specific availability zones, and you need to have in mind what happens if one availability zone has any problems. You need to have the failover to others and build this kind of network. And it's something you need to think about. When you use serverless components, they are distributed in the case of AWS, inside a region, and they're distributed around all the availability zones. So the high availability is kind of built in all the components, so you don't need to think about it. And most of the components, they have even global failovers that you can configure pretty simply. So basically, at the end of the day, what you will end up is a lot of Lego pieces, Lambda functions that are the way that you can write your code, Dynamo tables that are no SQL databases, API gateways that might be your endpoints, your applications, managed queues, workflows. You will end up with all these Lego pieces that you will root together with different configurations and different events that will move from one to another until you form something beautiful like this. This might look scary, but it's not. I think if we think about the traditional architectures where we have the servers, maybe it looks very scary because when we are building those traditional architectures, we have little boxes. This is a naked architecture. It has everything very exposed. All those functions that you see there, the orange boxes, are quite doing small things. And those other boxes are already managed services. So they are not code that you have to write yourself. So this is when you understand this diagram, it's not that scary. So I always like to show it because it's a very busy diagram, but at the end of the day, it's not that scary. So I want to start first, now that you understand a little bit what is the meaning of serverless and what we want to do with it, with the first story. That is my story. So as I said, I started with serverless in 2016. It was around May. And I was working by then, not in AWS, I was working in another company. And I was in the team that we were building Netflix for cartoons. It was not Netflix, it was another company. And we were building kind of streaming for cartoons for little kids mostly, and the little kids were watching and watching and watching and watching the same video over and over again. If you have little kids, you know that they can watch the same thing forever. And then we were maybe 5 years in business by then. We had around 6 billion views because kids like to watch the same thing over and over again. So we were had a lot of requests. We were very busy service. And we were monetizing through advertisement. And when you have this type of service and you're monetizing through advertisement, you are always in the edge because streaming video, images, text, everything is quite expensive from streaming it from the backend to your client. And we didn't understand any cloud economy when we built this. We were free backend developers, mostly Java developers. We were quite decent Java developers. We have zero understanding on cloud. But we built this application on AWS. We have a really good operations teams that basically abstracted all the pain of doing AWS, and we throw containers into the cloud. But well, it arrived May, the beginning of summer, and we got a call from our boss telling that our application was too expensive, that if we don't fix it, it might need to be, this project needs to be closed. And the developers of the team were like, no, we love this team. This is the best thing ever. And we started working very hard in optimizing the code. We added caches, we optimized the code, we make the algorithms more efficient. We did everything we could and nothing worked. Then we realized that basically we didn't understand how the cloud worked and we needed to re-architect our whole application. When we started looking at the re-architecture of our application, we realized that we will need a massive team to do everything ourselves. And that's when serverless started coming to the picture. Serverless was just coming and becoming popular. And I was doing some, after work activities. I didn't have kids, so I have a lot of time by then. To explore things after work. And I thought that I have this hunch that serverless might work because it had this promise that you don't need to manage infrastructure, that you don't need to build everything yourself. And with free backend developers and having such a big project, that was a good way. So I told my boss, let's go with serverless. And he said, sure. So we started coding and coding. And the first thing we did was to write some kind of prototyping to validate that our idea of serverless could work. We validated that everything was fine, good. And then we continue coding and coding, and months passes and passes and nothing happened. And we keep on coding. And then new features got added to the old backend. And months pass, and I think 9, 10 months pass. And one day we decided, okay, now we go to production. And we did. It was not fully finished, but it was quite finished. And it was the longest time. I think in my head it lasted for 1 year, but in the reality, maybe it was a couple of weeks of going to production. We failed so badly. We didn't have a good monitoring service in place. We didn't have a good CI/CD pipeline in place. We were putting in production code that we built 6 months ago. It was the worst experience of our life. So don't do that. Please don't follow our steps. We did a lot of things right, but we didn't do the whole thing right. We suffer a lot. At the end of the day, we managed to migrate our service, but it was not the right way. The best story, and this one is from one of our customers, is from Comic Relief. You're in the UK, so I'm pretty sure you know it. I don't need to give a lot of background maybe on this one, but it's an NGO that is getting donations to give to charity. They take the television one day with a lot of interesting comedians and musicians and whatever, and they get donations. So they have a scaling challenge like we did. They have a lot of traffic. Instead of having it around the year, they have it in 1 day. They have a peak of 350 donations per second. It might not sound a lot, but donations are a very critical thing because you cannot duplicate them. You cannot miss anything. Everything needs to be perfect. You get a donation and you need to process it. And the thing with this before going serverless is that the weeks before the TV takeover, they have to start stacking servers and creating all this massive infrastructure just for supporting this event. And this was very expensive, and it was impossible to have donations through the whole year. So there was a lot of limitations that they wanted to avoid. So they started the migration process also in 2016, and this was more or less the architecture: 3 little monoliths, Drupal monolith, the giving pages monolith, and the donate monolith. That's the one we want to focus. The donate one, that is the one that the most impactful, that the one that was taking a lot of effort, and the one that will return a lot of money if they manage to migrate. So they started asking the question where we should start migrating from. They have the first option, that is to start from the least critical part of our system. That's the option we did. We started with the least critical part of our system, and we arrived to our critical part like 10 months away, and we never put it to production. We never test anything, and they decided, no, that's not a good one. The second strategy they thought is like, well, we start with the most important part of our system, so we are done, and then we can start all the new features. And they realized that was not a good idea either, because, well, if they start with that, then they might not have verified a lot of things in the way, like if there are systems that they thought, like the foundational work, CI/CD pipelines are in place, monitoring tools are in place, and a lot of other things that we will talk a little bit later are in place. So they decided no. So what they decide is to combine these two strategies in a meaningful way. So what they will do is they will start migrating something that is nobody cares, to get experience. So they started with this image gallery, they migrated to Node with serverless and all the fancy things. But if they screw it up, nobody will care about this. So it was painless. In 2018, they start migrating other pieces of their infrastructure, again, to keep on building and building more experience in the team. They also built some shared components that they could use on their services. And then in 2019, when they were confident that they could go, they migrated the donate service. And that was what they wanted to do. After that, I don't think they migrated anymore to serverless, because the Drupal for their content, that's something I think it will stay. But they end up with an architecture like this. You can find the whole blueprint in that URL. And this architecture, what it has very special is that it's a very resilient architecture. Nothing gets lost, everything is catched by something if something is lost in the middle. So no donation is being left behind, everything is processed and nothing is duplicated. So it's a very nice architecture, but very simple at the end of the day. And this is, I think, one of the most important charts is the savings. In March 2015, for 1 year of putting this service up, it was $85,000. Even though this was paid by partnerships, still it's a lot of money for anybody. And the thing is that they could only take donations 1 day a year. So it took a lot of preparations just for 1 day. After their migration, they end up having a yearly budget of $5,400. And now they could take donations all year round. while the serverless part, the donation and other migrated parts, was $92 a year. And that's pretty amazing. And everything is built with good practices. So everything is infrastructure as code. They can deploy it again anytime they want. So it's something that is very maintainable and scalable. So I know you know this URL because you're all in UK. If you want to donate, you can do it right now because their backend is serverless. So basically the strategy they use and is a kind of a strangler pattern. They didn't have a monolith for the donate, but it was part of a big system. But this is also a good idea when you're doing serverless, if you have a monolith, to start strangling your monolith and taking services out and migrate them to serverless one by one. So this is the pattern we will analyze in 5 steps. So 5 steps to migrate to serverless from a monolith. First one is to do your foundational work. And this is a very important thing. If you have a monolith, you need to understand what you will end up with a microservice architecture, and you need to do your homework on deciding how your microservices will look. Conway, there is this law that says that the software represents the kind of layout of the organization and how the organization communicates. So if you want to have a good microservice architecture, it's recommended to organize your organization in the way that you want your software to be. Then pick your developer tools. Pick your developer tools, your frameworks, your languages. Have a thought about what will be a good tool for which service. You don't need to pick the same framework for all your architecture. You can choose, and there are many options and many reasons why to have different frameworks. Infrastructure as code from day 0. When even you start teaching somebody in your team about serverless, you start with infrastructure as code. It's the most important practice, I would say, in the serverless architecture. So then you can replicate the same infrastructure over and over again in multiple environments and in multiple accounts. Having a CI/CD pipeline is a must. You need to orchestrate your changes in, if you can, continuous delivery. That's the most important. Then you can start pushing changes out very fast. Sometimes you cannot because you have different clients in their side that cannot change. So you might need to have some manual approvals, but automate as much as you can and have a lot of automated tests in the place. And you start building this even before starting to code. And the same for monitoring and observability. Have tracing in place so you can trace all the requests that go through your system. You will end up with a distributed architecture where you cannot really debug in your code because everything will be distributed around the cloud. So you need to have a good monitoring in place. And all these things doesn't mean to be perfect from day 0, but you need to start implementing them in day 0. So then you can start testing and improving them as you go through in your migration process. That's why you want to start migrating first the less critical parts of your system so you can test these things out. And then when you are sure all this is working fine, then you can start migrating your most critical part of the system. And the steps are very simple. If you have a monolith, start organizing the code in the monolith. There is good monoliths out there. They already have nice packages or modules, and they are already organized. If you have that, that's great. You can avoid this step. But in some cases, monoliths are a very spaghetti code, and you might need to organize. Find what are the different boundaries of your project, where different context is, and try to group them together and organize it in a way. It will help your migration process. Then organize the code inside the monolith and make it work with your data layer. In this time, you will need to start breaking a little bit the data layer of the monolith into a little bit more organization to represent the different packages and the different bounded contexts. If you have an organized monolith already, you might not need to do this step. Or if you have microservices, you might not need to do this step. But I've been working with a lot of monoliths in the past, and they tend to be a mess. And then when you have your code organized, now you can start moving bit by bit gracefully. So we are doing the strangler pattern. We are not moving everything. We are start picking something that at the beginning is not very impactful and then moving it little by little to production and see how it works. So we will move this to serverless. And here are my express tips to move to serverless applications. So how we designed a serverless application. First one, think about logical microservices. This is, when we think about microservices, we think a little, maybe GitHub repo with code inside that is kind of making sense together and it's in a little application. Well, in serverless, we might not have applications because the code is in functions and they don't belong to an application. So you can think about logical microservice, a grouping of different functions and queues that will connect those functions and database component that will be, all those functions will be talking to, and orchestrating services that are organizing those functions as belonging into the same logical microservice. You can even put them in the same GitHub project and have, for example, the code and the infrastructure deployed together. And then these logical microservices have similar rules than normal microservices. They need to be deployed independently from one another, and they don't share data. The data that they have is private inside the microservice. So if somebody wants to get data, they might need to go through an API through the service to get to the database. For example, those are some of the rules. Another thing is to think about event-driven architectures. And this is very important. Will help us to do independent releases and to decouple our system, to have more modular code that we can replace in the future very easy. It will help us to maintain and understand what is going on. We really don't need to debug the whole application if something is bad, and also adds resiliency to our application. A lot of these the coupling services are queues and pub subs and event bridge that will retain the events in case that the service in the other side is not replying. So this will add a little bit of resiliency to your application. If something goes wrong, these little services that will be between your functions or your microservices will be retrying and waiting for the other service to recover without you needing to do that. So we have services like queues, one-to-one communication. We have services like pub-sub, one-to-many. We have services like event buses, many-to-many. And I particularly like event routers or event buses to connect microservices together. So when you build these logical microservices, you can create connections between these microservices using an event bus. An event bus is a funny thing because it used to be very popular in the past, and later with time it became less popular because it was a bottleneck in most of enterprise applications. But now with the cloud, it's not a bottleneck anymore. It scales very well. So you can put it between your different microservices, and all the microservices just register to the event bus, and then they can send messages around to all the other microservices. So it's a very easy way that keeps the whole system very decoupled, because when you add a new producer or consumer of messages, it just needs to register to the event router and nothing else. The others ones don't know about it. So it's a great way to add support for your microservices in a big enterprise, or even for external resources. The next step is to orchestrate your functions in workflows. And in a lot of cases, we need to have functions that are doing small things that need to coordinate with other functions. So we could do that manually. We could create the code for that, but we don't need to. There's a service in AWS, and there's another cloud providers, similar service that will do that workflow management for us. So it can do parallel workflows or series, doing analysis of the data. It can try retries if something fails. It can do try catch. So it can do a lot of interesting flows with our data. It can even do manual approvals if we need to. So it can make a lot of interesting logic to our data, and we just write the smallest functions that we can, just the business logic, again with the mentality of not reinventing the wheel. And this is a nice rule of thumb. You want to orchestrate within your microservice, and you want to choreography between the different microservices. And this is a good way to think about when architecting a serverless application: orchestration inside the logical microservice, and choreography, that is this event-driven, for example, event bus type of thing outside of the microservice. And then another step is replace what you can with managed services that are existing already. And this is part of the serverless philosophy again. For example, if you have authentication layer that you have written, replace it with something that is already provided by the cloud or by the market. For example, I just put an example of Amazon Cognito. It could be Auth0. There are many out there. And this applies for anything else. Do you need to manage your own database? Do you need to install it in a virtual machine, or can you use Dynamo or RDS or whatever? Or do you need to, I don't know, manage your own queues or manage your own Kafka? can you use something that is already provided by the cloud and replace as much as you can with those. And then we go back to the steps. The next step is to break the database. So if you have a monolith, you will have one big database, in general, a SQL database that you will need to break into pieces and to migrate it in smaller databases. And if you already have a microservice, you will have a small database. But if it's an old service, it's for sure a relational database. And here is a good moment to start thinking about what are your access patterns and what is the access of this data? Are you going to have a lot of throughput? Are you needing to scale this database? Will it handle? And here, if you really need, it's a good time to move to NoSQL database or file storage or something that is more scalable. In some cases, no, but it's a good moment now that you're doing the migration to think about your database. And the last step is to move your APIs from the old system to the new system. And you can do that with a load balancer. There is the application load balancer. And this is a feature I will have loved that will be there when I was doing my first migration. That is the capability of doing weighted targets. So I can define in my application load balancer that 90% of the traffic goes to the old backend and 10% of the traffic goes to the new backend. And then I can start moving traffic slowly and make sure that everything is working fine. When I did my migration, that didn't exist. So we needed to switch everything and all the traffic was coming in and we were like, whoa, wow. And it was very painful. So this is a feature that you really need to embrace as much as you can, to move your APIs in a slowly way and start testing the traffic in little amounts, and it will make your life so much easier. And that's it. Those are the steps. I know I simplify a lot, and this might take many, many months or even years to do the whole migration, but I have seen this same pattern repeat over and over again in different customers. And if I look forward in my stories, in the things that I have done, I can see maybe not in this order, but they are the same keys repeating in all the successful projects. So yeah, that's it. And if you have any questions, I can take some questions. I have maybe 15 minutes before I need to run.
Hi, Solomon here. I thought what you said was very interesting, actually. In terms of, I don't know, I'm trying to figure out if I could use something like Django for this whole serverless. So like an API. So Django is a Python API framework.
Yeah.
And it's generally like, in a way, I think it's kind of monolithic in a way, because all the APIs are bunched into a main
Yeah, it might be like Node and Express, something like that, I imagine.
Yeah, but yeah,
there is many examples. Like in this case, I was showing you how to migrate to a serverless application that it's really distributed and you are not having like a monolith function. But there are many production out there of serverless using little monolith inside a Lambda function, and you can definitely do that. I never use Python, so I cannot tell you exactly for Django, but for example, for Node and for Java, that are the two languages that I know, you can basically migrate a whole application into a Lambda function, and it works. There are limitations in Lambda functions on this package size. So I think it's like 250 megabytes in bunches of 50 megabytes. So you need to look at those limitations on how big your application is. And a Lambda function will run for 15 minutes. So that's something to evaluate. But in general, like this type of APIs, they can work quite decently. And they're a good initial step into going to serverless.
Okay, cool. Thank you very much for that.
Somebody's asking a question in the chat. What technology could we use for the event bus? Well, the event bus is, if you're using AWS, we will use Event Bridge. It's a service from AWS that was launched last year in July, so it's less than a year old. And I think after Lambda is the best launch that AWS did, because this event bus is based already in technology that was there for a while, CloudWatch events, and you can basically send JSON events to this bus. So you have a producer of events that is sending JSON events to this service with, I don't know if you're using AWS, through the AWS SDK, you just send a message, and then the bus will have a set of rules that will decide, okay, if the message has this body or is coming from the source, and the rules can be super, super duper precise. You can go to the detail. Then I will route the message to here. And you can route the message to multiple different consumers. And it's a great way to orchestrate and have an event-driven application. So that's my recommendation. If you're inside AWS, use Event Bridge. It's a super scalable and super distributed event bus.
Marcia, thanks for the presentation. Just a quick question around Lambda specifically. Are there things we should be aware of when we start or in the startup of a Lambda session? If I understand correctly, it can be used for synchronous function or synchronous payload. But is that the right understanding?
Well, Lambda has support for synchronous, but I will not recommend it to use for synchronous communications because it's designed for being asynchronous mostly. But in my experience, unless you have a very specific case, you can really re-architect most of the code into being asynchronous, and it will improve the performance whatsoever of your application. So it's something just to change a little bit on the mindset, and most of the services that are internet-based can be switched to asynchronous. But sure, right, everything can be switched to asynchronous. So I don't know what is your use case, so I cannot tell you. But
yeah, for example, if we have steady stream of data coming across the day.
Yeah, so if you have streams, you can use a service that goes in front of Lambda that, for example, is designed to work with I cannot say that word in English, high throughput. For example, like Kinesis, that is for ingesting streams of data, and that is working real time. So basically data is coming in and it's being ingested and it's being forwarded to Lambda automatically, so you can do even processing there. And if you have so much data that you cannot handle it in Lambda, you can send it to containers, you can send it to EC2s. Right. So you can always use these Lego pieces, and the hard part, I think, from doing serverless applications right is to know all the AWS ecosystem to find the right Lego pieces. You don't need to know them in depth, but you need to know what they are doing to find the right Lego piece to solve your problem.
Okay, all right, good. Okay, thank you.
No problem.
Hi. Yeah, sorry.
Did you say something? I'm not sure if you mentioned it. Is something like step functions also something?
Yes.
Yeah, when we're doing the serverless architecture.
Yes, step functions is a great service for orchestration. So basically, it will allow you to create state machines, and in those state machines, you can put whatever. If you use it for orchestrating your Lambda functions inside the state machines, you will design it with different Lambda functions. So after this Lambda function finish, goes here, or you can have conditionals, like if this happens, goes here, if not, this go here, or you can do calling also into different services, not only Lambda. You can put messages in a queue or directly into a table, or you can even have a manual approval, like you need to have a human to come and tick a box. So step functions are extremely versatile in what you can do with them. But at the end of the day, what you have is a state machine with all the workflow of what the different little lambdas will do. And then your code will come from one side and it will do the magic and then go and output in the other side. So for example, one thing I use step functions and I really like it. We have to process, I don't know, how many files, and it was in all the languages available. We need to have the process. So we have a state machine that was inputting the files. And then we have a parallel of all the languages every parallel was a different language. And then the step functions, what it did, it wait for all the languages to finish executing, and then it will grab all the results and feed it into the last Lambda function that was generating the output. So that you can do yourself, but you will need to add a lot of code and logic for it. In this case, you're just drawing the state machine and say, okay, I want all these parallel executions. These are all my functions, all the different functions I will have. And it just happens. You don't need to manage the timing when everything finishes or what to do with it. So it's a very nice service. So
Yeah, thanks.
no problem.
Hi, just have one question. So one common terminology we often come across while working on Lambda is the cold start, right?
Yeah.
So is there a mechanism that you have to improve this?
Yes, there is this concurrency provision or something like that.
Okay.
Basically, what you do, I don't remember exactly the name, but what you do is you reserve some kind of concurrency and you're warming up the Lambda. So you say, I have this Lambda function and I want it to have a provision concurrency of 10. So when you deploy the Lambda function for the first time, there will be 10 functions already ready. So whenever your first 10 requests come in, they don't need to wait for anything. And then they will, because when the whole system is working, then the functions will be already warm up for you. So that's, oh, somebody put it in the provision concurrency. Yes, that's the
Okay. Name. Okay.
Yeah.
So when it's not used, the count goes down?
No, it will be always 10. So that's
always
the
10.
thing.
Okay.
And you're always paying for those 10. So it's kind of, it never goes to 0. So that's why you never have the cold starts, because there was always Lambdas warm for you.
Okay, thanks for that.
No problem.
I think we also had a question from Richard in the chat.
Okay, I don't know what BPM stuff is and ESB. So this is something maybe Richard can explain me more. What is this question?
Yeah, so you were talking a little bit before about you know, the fact that it was quite popular to put services onto enterprise service buses, yes. And then kind of, you know, have some kind of orchestration around that. So
yes.
Typically we'd have some WSDL that describes the service and how to interface to it, and then we'd have, you know, something written in some kind of BPML
that
would orchestrate. Yeah, and so does this look quite similar to that stuff? And
so basically, as I said, the event bus, I don't know how this looks because I never worked really with these enterprise buses. I just learned from it.
Mm-hmm.
but basically how Event Bridge works is that you define rules in your bus. And with those rules, then when the events come in, they will know, event bus will know where to direct the events. So all the logic is written in the bus, and the event producers just emit events, and the event consumers are just kind of waiting for those events. And they know nothing about each other, and they don't know anything about the rules. So the rules are all put inside the event bus, in this case, Event Bridge. So it's very easy to decouple the services because you can just throw a new service in and remove the other service, and you don't need to register anything anywhere. So I don't know how this BPM work, so I cannot tell you if it's similar to it.
Yeah, I mean, it would be similar stuff. You know,
okay.
So.
Yeah, I imagine they didn't reinvent the wheel, so.
Yeah, and really, what I'm interested in is, you know, what's actually, you know, because that stuff typically was quite slow and cumbersome. Which was,
this is not slow, and this is very fast and very scalable because it's using the backbone of the cloud. So you don't need to worry about how many events. It's not as fast to ingest data maybe as other AWS services, because it's not meant to just stream data into, but for a microservice architecture where things are just sharing data in normal ways, it's totally perfect, scalable, and it works very well. So definitely take a look at it. And I have not heard anybody complaining about the scalability of this service, because it has all the good stuff from the old times and the good things from the new times.
Yeah, cool. Thanks.
No problem.
Perfect. Did anyone else have any other questions or anything they'd like to ask or cover off? No? Perfect. Well, thanks a lot for your time, Marcia.
No problem. Thank you for inviting me.
Great having you and obviously getting your insight there. and hopefully it went down well with everyone else. So yeah, thanks again for your time, and yeah, really enjoyed the talk.
Thank you.
Yeah, awesome. Thank you.
Thank you.